all of yesterday and the day before, we always had a two-way table. A weird question to ask, but what does it mean if we have a two-way table about our data? What kind of data do we have if we have a two-way table? How many variables? 2, because it's a two-way table. The last one that we have, which is our notes for today, is not going to be a two-way table. It is just one category that we're seeing. Does it match or does it not? So let's start with our blank generic. So I gave you a blank generic in front of you. You should have one. So what happens is, and we've done this both ways, because we started with the more complicated one, which was yesterday and the day before, going back to this one is really, really easy. So this is, we're doing a generic four-step process for chi-square test. Chi-square, I like writing GOF first. It's a goodness of fit test. So write it down. Does that ring any bells right now? You shouldn't know goodness of fit, but does that? In the calculator, there's an option that says what? GOF. So that's our GOF right there. And this is number 13. We're still in chapter 11. We'll see if I'm making sense. Where do we start with state for the other ones? Are we still going to have population if we just have one category? Yeah, we're still, even though we're only dealing with one category, we're still going to have population that we're dealing with. I don't care if you write in 2 colors like I do, but you're going to need to pay attention to the way I write the colors for state so that you can actually, because otherwise you won't know what you actually write and what you don't. So population, we define it in context. All right, so what's the next thing we do for yesterday? Null and alternative hypothesis. We don't have to define anything before we do the null and hypothesis. Basically, why? How short or descriptive is our null and alternative hypothesis? Yesterday. It's long. It's descriptive. We write out literally everything, so we don't need to define anything beforehand. We're not writing out the entire thing word for word here, so we do actually have to define something. So we're going to be dealing with proportions. So we're always going to define it as PI, which means I have multiple different proportions. Freshmen, sophomores, juniors, seniors. That could be P, I can do it as a grade, P9, P10, P11, P12. This means I have multiples of this. And then so that we're going to define that as the proportion of whatever in context. Now, a lot of times you're going to have a key there too. And just because I want you to know that you can do it this way, I want you to write that. So like if I did something with grade levels, and it was high school grade levels, and I did my subscripts as 9, 10, 11, 12, do you think I would need a key? Or is that really explicit? It's pretty explicit. 9 is 9th grade, 10 is 10th grade. But sometimes you might need one. like if I made a key, it would literally be like 9 equals 9th, 10 equals 10th, so that's pointless. If you're using letters to be a subscript, just like we've dealt with before, then you would need to define them, and that's what I mean there. In some cases, yes. So like, but a lot of times if it's like, it's hard to answer that in 20C1. Y'all won't have an issue with that. I'm going into more detail than I need to there. And then we still have to have our null and alternative hypotheses. So our null hypothesis is going to be what we are claiming that each of the different probabilities are. So I'm writing this in my other color because it's going to change every time. I'm just going to write like P1 equals number, P2 equals number, ... But it's not always going to be a P1 and P2. It's whatever subscripts you define. And there's not always going to be 2. It's not a set number. You can have as many as you want. Now, our alternative hypothesis, and this is why I'm saying colors is important here. We are literally going to write word for word the exact same thing every single time. So here I'm saying this proportion has to be this one, and this proportion has to be this one, and this proportion has to be this one. So for this to be wrong, how many things need to be wrong? I'm saying this means this one is right, and this one is right, and this one is right. So for this claim to be wrong, how many things have to be wrong? Just one. So we literally write at least one of the PIs is incorrect. And that's what I'm saying about colors is some people think they really need to fill something in there. You don't. That's literally what I want you to write every time. And then what else do I always have to state? Plan. Where do I start plan? Method. What do you think our method's going to be here? Think about the calculator. And GOF is fine. What is my first condition? I still don't think we need to write anything out for random right now. We know what that is. Random selection, random assignment. You do either one. What's my next one? Now there's one thing that I'm going to come back and talk about with that. It's easier to talk about with a example. But what are we checking with large sample size? So all expected counts still have to be greater than or equal to 5. I'm just doing this to show what's different. Now you're just going to have like one thing like this where you fill in all values. I don't care if you really write that down or not, but there is something off to the side that I'm going to come back and write. And then what's our next condition? Which is Now, is this going to be the case like with yesterday to where there can be multiples? Because look at this is only one population that I'm dealing with here, so it can't. So we're literally only dealing with one. We don't have to worry about what we just talked about with homework. As soon as I finish this, I might get everybody to go back and write something with random and independent for yesterday's little blank. And then there at least, if you want to write that part. Do, what's the first thing we wrote for do yesterday, day before? How did we find degrees of freedom yesterday? Number of columns minus 1 times number of rows minus 1. Can we do that now? Because number of rows would be 1 and then that'd be 0. So instead, these are categorical variables. So like 9th grade, 10th grade, 11th grade, 12th grade would be categories. So how do we find degrees of freedom in general? We just take that and do what with it? So we just call it number of categories minus 1. Chi-square we did the exact same way that we did before. Again, I kind of wrote this a little bit funny the other day. I would probably write it however you wrote it before. But it's the exact same math of what we did. Where this is my first value, and this is my last. But that's the exact same way that it was before, so however you choose to write that, I know I'm doing weird colors, but this is the exact same math as we did the first time, so I don't care how you choose to write it to show that. Alright, so I've got my chi-square value, I've got my degrees of freedom, now I do what? Draw it and shade it. What kind of shape is chi-squared? And which direction are we shading? To the right. If it makes you feel better to draw a line here and do this, because it's always going to look like that, it depends on how far it is. If you think you're going to forget that it's always to the right, you just need to put your number there. And then out of that, we get our what? Which we compare to our and we determine if it is conclusion. Even though we just changed a couple little things, you could probably write conclusion without me saying anything or work through to figure it out. So we're starting with what? What is it that we reject or fail to reject? So it's what? What are my options? You don't have to, because we're gonna end up like they're either the same or they're not. but they're all the same or one's different, and we're gonna write it out with one being different. What are my options here? And is or is not what? Which means that we, options. Now I'm gonna write this in the different color because some of the times it makes more sense to write it in context, but you don't have to. So that part, at least one of the PIs is incorrect. You could technically just write it like that, but most of the time people write it in context because it actually makes sense. How do I need to end that? For population. Let's go ahead, and I said I was going to write this, or tell you to write this. The one from yesterday, with random, I would add something about if random selection random from each population. Random from each population. Or I'll break something. And then for independent, if random selection, 10% condition for each. This is, so yes. So if we do random assignment, we don't have to do this. So if we do random selection, we do. Yeah, this is for yesterday's. So this is the part that we were talking about with the homework that I did not do yesterday. And if you're writing, I'll click it back up